class 10 science chapter 5 periodic classification of elements, and in this video we will discuss about modern periodic law, modern periodic table and position of elements in the modern periodic table. Henry Moseley showed that the atomic number is a more fundamental property of an element than its atomic mass, and according to it the modern periodic law is given, and this is the statement of this modern periodic law. The physical and chemical properties of the elements are periodic function of their atomic numbers. Modern periodic table. Various forms are available, but long form of the periodic table of the elements is more convenient and widely used. In this, the horizontal rows are called periods and the vertical columns are called groups. There are 18 groups numbered from 1 to 18 and 7 periods from 1 to 7. In this form of the periodic table, 14 elements of both 6th and 7th period. These 14 elements of 6th period are known as lanthanoids, and 14 elements of 7th period are known as actinoids respectively, are placed in separate panels at the bottom. This is the modern periodic table. These are group numbers. This is 1, 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13, 14, 15, 16, 17, and this is the 18th group. And these are the periods 1, 2, 3, 4, 5, 6, 7. The elements which are represented by this color, these are the metals. Elements which are represented by this color, these are the non-metals. And the elements which are represented by this pink color, these are metalloids. This. Okay, and these metals and non-metals are separated by this zigzag line. Okay, and again see, this is after lanthanum. This is lanthanum, atomic number 57. There is 14 elements starting from atomic number 58 to 71. These are known as lanthanoids. In the same way, after atomic number 89, it is actinium. After actinium, there are 14 elements starting from atomic number 90 to 103. These are known as actinoids. These are given separate position at the bottom of this main periodic table. Okay, and this hydrogen is given separate position because its properties are resemble with the first group element and 17th group element. That's why it is given separate position. And elements belong to group 1, group 2 and group 3, group 13, 14, 15, 16, 17 and 18. These elements are known as representative elements or main group elements. Again remember, elements of group 1 and 2 and 13 to 18 are known as representative elements or main group elements. Modern periodic table takes care of the limitations of Mendléev's periodic table. How? Just see, positions of cobalt and nickel are as per increasing order of atomic number. Cobalt atomic number is 27, nickel atomic number is 28. In the same way, positions of tellurium atomic number 52 and iodine atomic number 53 are in increasing order of atomic numbers. Isotopes of the element have same atomic number, so there is no need for separate position for isotopes. Atomic numbers increase in regular manner and atomic numbers are not in decimals or fractions. Hydrogen is given a separate position in the modern periodic table. In this way, modern periodic table removes the limitations of Mendléev's periodic table. Positions of elements in modern periodic table. First, we'll discuss about groups. See, these are the elements of group 1. Lithium, sodium, potassium, rubidium, cesium and francium. First, write the electronic configuration of first 3 elements which we have discussed in the class 9th. Okay, that is lithium. Electronic configuration is 2, 1. Sodium 2, 8, 1. potassium 2881. And if we observe this electronic configuration, we can say the outermost shell, that is also known as the valency shell, and electrons present in the valency shell are known as valency electrons. All these elements have same number of valence electrons, that is 1. And group 1 metals or elements are known as alkali metals. Now again see group 2 elements: beryllium, magnesium, calcium, strontium, barium and radium. Write the electronic configuration of first 3 elements. Beryllium 22, magnesium 282, calcium 2882. Again observe number of valence electrons, that is electrons present in the outermost shell. These are 2. And these elements, that is group 2 elements, are known as alkaline earth metals. Again observe group 17 elements: fluorine, chlorine, bromine, iodine, astatine and tennessine. Okay. Now if we write the electronic configuration of first 3 elements of group 17, fluorine 27, chlorine 287, bromine 28187, again find the valence electrons. These are 7. And group 17 elements are known as halogens. Okay. Now if we compare the elements present in the same group, what is the common among them? We can say elements present in any one group have the same number of valency electrons. Okay. Groups in the periodic table signify an identical outer shell electronic configuration. And we can say number of shells increases as we go down the group. In each case you can say, in that this is lithium, this belongs to the second period. Okay, this is the second period. It has 2 shells, this has 3 shells, and this has potassium has 4 shells. Down the group, number of shells are increases. Okay, and that's why we can say elements having similar outer electronic configuration in their atoms are arranged in the same group. It means if we know the valence electrons, we can identify the group in which elements can be placed. Okay. Now see periods. These are the second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. And their atomic numbers are given 3, 4, 5, 6, 7, 8, 9, 10. And write the electronic configuration. Lithium is 21, beryllium is 22, boron is 23, this is 24, 25, 26, 27, 28. These are the third period elements. Atomic number 11, sodium. Electronic configuration 281. Atomic number 12, magnesium 282. Aluminium 283. Silicon 284. Phosphorus 285. Sulfur 286. Chlorine 287. Argon 288. Now again compare the electronic configuration. We can say that is elements of the period do not have the same number of valency electrons. Clear? Valency electrons are increases as we go from left to right across a period, but they contain the same number of shells. You can say that is second period element have 2 cells. Okay, these are the 2 cells, and third period elements have 3 cells. Is it clear? And each period, you can say each period marks a new electronic shell getting filled. It means in the second period will start by filling of second cell. Third period element start by filling of the third shell. Okay. In the same way, we can proceed to the fourth, fifth, and sixth and seventh period. Number of valency shell electrons increases by 1 unit as the atomic number increases by 1 unit on moving from left to right in a period. Okay, and we can also say number of period is equal to number of shells. If we want to find out in which period element is present, then write the electronic configuration, find out the number of cells. Number of cells will give the number of period. Elements with same number of occupied cells are placed in same period. Okay, if different elements are given to us and if they have same number of cells in which electrons are occupied, then we can place these elements in the same period. Now the position of element in the periodic table tells us about its chemical reactivity. The valence electrons determine the kind and number of bonds formed by an element. We have discussed about the formation of ionic bond and formation of covalent bond. Ionic bond is formed between metals and non-metals, and covalent bond is formed between non-metals. Okay. Then how many elements are present in the periods? You can find out number of elements in the period. This number of elements in the period is based on how electrons are filled into various cells. Detail of this you will discuss in the higher classes. Okay. Maximum number of electrons in a shell is given by the formula 2n square, and this table indicate the number of elements present in a particular period. In first period 2 elements are there, in the second period 8 elements are there, in third period 8 elements are there, in fourth period 18, fifth period 18, sixth period 32 elements, and seventh period 32 elements. The detail of this is not in your syllabus. You will discuss in the higher class. Then how can we find out the group number and period number of an element? Or in this class, that is up to your standard, we only discuss about the representative elements. Now what are the representative elements? Elements of group 1, 2 and 13 to 18 are known as representative elements. First write the electronic configuration, okay, and find out number of occupied cells, and these cells will give the period number, okay. And to find out the group number, if valence electrons are 1 or 2, then group number is equal to number of valence electron. If valence electron is 1, group is 1. Valence electrons are 2, group is 2. If valence electrons are more than 2, then group number is equal to 10 plus number of valence electrons. Okay, let us see some examples. Z is equal to 4. If atomic number is 4, that element is beryllium. First write electronic configuration. This is 2, 2. How many cells are filled? 2 cells are filled. That's why period is 2. In the valence cell, that is how many valence electrons are there? 2 valence electrons are there. That's why group is 2. Atomic number is 9. Fluorine. Write the electronic configuration. This is 2, 7. Again 2 cells are filled. That's why period is 2. Then how can we find out the group? Group. If 3 or more electrons are present in the valence shell, then add 10 in the number of valence electron. That's why you can say this is 10 plus 7. This is the group number 17. Atomic number is 11. Electronic configuration is 281. Now you can see 3 cells are there. This is K, L, M. That's why period is 3rd. And group is this. Valence electron is 1. That's why group is 1. Z is equal to 14. Electronic configuration is 284. Again 3 cells are filled. That's why period is 3. And a group is that is add the 10 in this 4. 10 plus 4 will get 14. Z is equal to 18. Electronic configuration 288. To which period this element belong? Yes, you are correct. This is period is 3. Then which is the group? Which is the group? Again add 10 into number of valence electron, that is 8. Group is 18. Atomic number is 20. Calcium. Electronic configuration is 2882. Now again, now I think you have clear. Which period? Yes, period is 4. And group, number of valence electrons are 2. That's why this belong to group 2. Is it clear? Thank you. Subscribe my channel to get the new videos.